Foundations of Algebra. This is supposed to be week 6, but in my class, it might be week 7 because I think we hit a roadblock with the scientific notation. And that's because, like I said, we're accelerating the pace. So the scientific notation assignment has multiple things in it because this is math 8, and so I'm trying to speed it up. But I'm not trying to lose anybody. So what I want to show you right now is if I'm speeding it up and you say, Mr. Fields, slow down, what you can do is you can take some extra time before you get to class to slow it down on the individual level, if you would be so bold. So this, what I'm looking through is Math 8. All right, I've taught Math 8 for a few years now, and you can see all of the things that I'm grouping together for us are individualized. If you go to the Math 8, you can see a whole video. Okay, so here, I had to scroll down a little bit, but scientific notation. So the quiz covers powers of 10. It covers, here's the intro to scientific notation. Here's the one where I only do adding and subtracting. And yeah, I multiply and divide in this one. So you can find the video where I do just the one, and there's lots of stuff on this website. So, but we're gonna try again here with this video to keep the pace here so that we can get our goals achieved. So I am going to do quiz 2, numbers of solutions, but go back to Math 8 and do the number of solutions videos and separately if you want some more information from me before you get to class. Try the assignments before quiz 4 here. You just click back and you can do that. Okay, so let's go. All right, so why is there so much all right, without any equipment, you can see stars that are 2,800,000 light years away. By looking through a small telescope, you can see stars that are 3,112,000,000 light years away. Approximately how many times further can you see through a small telescope than without any equipment? So you have to know, what are we doing? Multiplying, dividing, adding, subtracting. Anytime you want to know how many more times something is bigger or, how many stronger or something, that's division. So when I saw this, when I saw this right here, I knew that it was division. So I wonder, did you know that it was division too? If not, then what we should do is make a list of keywords, and as you go through this assignment, mark down when is it division, multiplication, addition, subtraction, and start to link the keywords with the operation that you see in that problem. And then as you go on, you will also know the keywords. So let's go ahead and write out our numbers. I could write them out in scientific notation and divide them, and that would probably be good, but I did that in the last video. So this time I want to start off by showing you the standard form. So if I put them like this in standard form, I can just cancel out the zeros as far as they go. And so it was 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. So then my numbers are just 3, 1, 1, 2, 0 over 28. And so anyway, it's approximately, right? So we can see if I divided, if I round these, it's like 31,000 kind of over 20 over 30 or something like that. So then that would be 3,100 over 3 which would be, that would be like 1,000, right? So I'm gonna say C. And so, but that's just approximating. So let's make sure I get it. I got it. Okay, we can all agree. So so what did I do here? I put them in, I knew it was division. I put them in standard form over top of each other. I started crossing out the zeros. And then I got this. And then I said, it says approximately. You heard me say it. And so what I did was I rounded that top number to 31,000 and I rounded this number to 30. So I rounded because approximately means round. And then I said 3,100 over 3 is approximately 1,000. It's a little bit more than 1,000, but it's approximately 1,000. And so that's what I did. All right. A worker bee has a mass of what is the mass of all the worker bees in the hive together? So when I see this, I know that I'm going to add. Okay. Wait a minute. It depends on the given information. If they give me a bunch of masses of worker bees, then I would add them together. But now I see it has a mass. This is one worker bee, and then there's this many worker bees. So when I see that, I know I am, what is it? Multiplying. Hopefully you said multiply. So let's multiply. 1 times 10 to the negative 4 times 4 times 10 to the 4th. Okay, so when we multiply numbers in scientific notation, we multiply the whole numbers there. We add the exponents, which would be negative 4 plus 4 is 0. So 10 to the 0 power is 1. It's 1, so that's just 4. So was the mass of all the worker bees, could it really be 4? Let's see. It's not, so what do? We go to, that's what I said. Oh, look, I had that, but it says put it in scientific notation. That is not fair. I got it right. But, you know, it'll happen to you. So I'm glad it happened to me so that it doesn't have to happen to you. Look at that gray circle there. All right. Express your answer in scientific notation. I will. Here we are adding again. I want to change this one so that it's 7. So right now, I want to do my 0 analysis. So I know that this would have 6 decimal moves, which means 1 decimal move and then 5 zeros. So it has 5 zeros. Doing my 0 analysis. I want to change it to 10 to the 7th. So that means I would need an extra decimal move. So I'm going to make it like that. Then there's 2 decimal moves and then 5 zeros. So we can do that in class. If that didn't make sense to you, that's okay. So I got 0, just to write that again, that's 0.65 and then 7.9. So I'm going to add those together. And that's 5, and then that's going to be the 15 and 8. 8.55. Hey, it's still in scientific notation. I don't have to do the little change at the end. A lot of these problems, you get a number in the teens, and then you have to adjust it in final time, but not this one, I don't think. Okay. All right. How many total copies sold? So we got their first album, their second album, so we're adding them together. Okay, so you can add them together. I just did that. And then this one, okay, we are approximating. I did that, approximating. Okay, you can do this one, or you can ask about it. All right, so there's some more review about scientific notation. So now let's move on to our Algebra 1 topics for this week. Hopefully it's a little easier for you too. So solutions to two variable equations. All right, so now we're looking at linear functions or linear equations with two variables, bivariate, x and y. And so we have our coordinates, right? We know that's x and y. So which one of these coordinate pairs satisfy the equation? How we would figure that out is just substitution. So we take the 11, we know that's a y variable, and the 1 is an x, and we substitute them into our equation. So 11 equals 8, 1 plus 3. That's 8 plus 3, that's 11. So we know that A works. How about negative 5, negative 1, negative 5? Let's substitute negative 5 in for y. 8 times negative 1 plus 3. See, just put that in there. 8 times negative 1 is negative 8 plus 3 is negative 5. It works. The answer is C. They both work because at the end of the day, I got the same number on both sides of the equal sign. So because there's an x and a y, there are many solutions to an equation. And so you have to check and see by substitution which ones work out of the given choices. And then this one is very similar. The only difference is now they give you one x and they ask you if this is your x, what would the y be? So what are you going to do? You're going to take that x, that information that you have, and you are going to substitute it. Okay, so we're going to write negative 5 minus 5y equals negative 15. And then we're going to solve. All right, so put our variables on the left, numbers on the right, constants on the right, I should say. Over the line, change the sign. We know that, so we're going to make it a plus 5. So this guy is going over the line. Negative 15 plus 5 is negative 10. Divide by negative 1. And you get 2. Y equals 2. So let's try that out. 2. Is it right? It's right. Okay. So that's the first part. The next thing we're going to do is slope. This week, I know the first part of this video was not about slope, but this whole week, the theme really, the Algebra 1 theme is slope. So a line, a graph of a line in 7th grade, you start with the constant of proportionality. That should be something you remember. But that's all about a line. And so what is the difference between lines? Well, one difference is they can be higher or lower, but another difference is they can be steeper. So the steepness of the line is called a specific name. It's called the slope. The slope is a ratio, all right? And it's the ratio of y to x, and we can just pick 2 points, so we get a formula. Formula is the slope formula, which is y2 minus y1 over x2 minus x1. And furthermore, the slope is represented by the letter M. It's French. The word in slope that they use is something means to climb. So anyway, just know that the slope is represented by the letter M, and we need 2 coordinate pairs in order to find the slope. The first coordinate pair is going to be x1, y1, and the second coordinate pair is going to be x2, y2. So let's find some ordered pairs that will help us. On one right here, or 2, that will be a good one. And one back here, -4, -4. So I was looking on the graph for, oh, I don't want that one. I want to use this one right here. although it doesn't matter. It's just, I like to use ones with zeros. It makes it less chance I'll make a mistake. So this is going to be, and it doesn't matter which one you make x1, y1 either. Just make sure, this is x1, that's got to be y1. If this is x1, that couldn't be y2, because, it's just ridiculous. All right, so now we got it. I've labeled, so I found my points that were integers on the line. That was the first part. Now I'm going, then I labeled one of them x1, y1. I labeled the other one x2, y2, and now I substitute them in to my formula. So y2 is 2, y1 is -1, x2 is 4, x1 is 0. I do the math, so that's going to be 3 on top over 4. And that's the slope, 3 over 4. Tells me every time the y changes by 3, the x changes by 4. It's a ratio. All right, and so we're going to look at slope from all different angles, but we're just going to use that formula. Oh, okay, so the ratio is every time the y changes by 1, the x changes by 4. And if we have a point at 6, 3, right? So let's put that point at 6, 3. And now we're going to, wait, you want to think about it. Instead of the every time this changes by, you just think up, down, left, and right. So we're going to go up 1 and right 4. All right. But I want you to learn to make a little slope chart because of the mistakes that I've seen over the years. So if the slope is 1/4, then you can do one of two things. You can go 1 up and 4 to the right, or, so that's 1, or you can go 1 down and 4 to the left. That's another option you have to get that second point. So I want to show you. I can go 1 up and 4 to the, oh, I ran off the graph. So that's why I need my second option. I can go 1 down. See, now it's 1 down and 4 to the left. Should be 2. Let me see. So you want to know your options because sometimes you'll run out of room. So like here, I got the 2, 3. That's my point, and I'm gonna go. Oh, the slope is -3/4. Let me show you that. -3/4, right? So this time I would go 3 down and 4 to the right, or I would go 3 up and 4 to the left. The mistake people make is going 3 down and 4 left. Don't do that because that would be a positive slope. So let's see. Can we go 3 down? 3 down, 1, 2, 3, and 4 to the left. Oh, we can easily do that. So, oh, did I mess it up? I did. I did go 4 to the right. I feel like I went 3 down, and 4 to the right. It says 4 to the right, doesn't it? Oh, Mr. Field. And see, I should have known that because you see, the slope is negative. The line should look like that. When it was like this, you see that slope is positive. And I'm glad I made that mistake because I'm sure someone on this, will make that same mistake. So I make another mistake. This is, you know what? You're gonna have to go 4 over. All right. So there you go. You don't trust me anymore, I understand. But I just wanted to make the mistakes that I know you'll make, So now you've seen it. All right. Let's get back to it. Let's get slope in a table. Okay. Do you remember the slope formula that I told you at the beginning? y2 minus y1 over x2 minus x1. Guess what? We can do that with these. We just pick any two. And there's your x2, y2, and your x1, y1. So let's call this x1, y1, and then this will be our x2 and our y2. So it's going to be 5 minus 10 over 49 minus 45. Maybe 4, it's going to be negative 5. So negative 5 over 4. I got it. First try. Look at that. So I hope that this video was helpful, and I hope you enjoyed seeing my mistakes, and maybe you knew that they were mistakes before you saw them. And now you don't have to make them yourself. You can get an easy 100. Come to class with all your successes, and I will see you there.